students, today we are going to discuss the concept applications of matrices in the topic matrices. In our last lecture we have completed the inversion method to solve the system of linear equations in two variables as well as in three variables. Today we are going to discuss the another method, that is reduction method, to solve the simultaneous linear equation as a matrix method. So before that we will recall uh, type of matrices, that is first type is upper triangular matrix. So let us see the definition of upper triangular matrix. A square matrix, first of all, see, this is the type of square matrix in which every element below the diagonal is 0 is called as an upper triangular matrix. In the concept types of matrices, we have already discussed this, but related to reduction method, I will explain it again. Now see here, all elements below the diagonal is 0, then the matrix is called as upper triangular matrix. Now suppose A is equal to the matrix in symbolic form, it is Aij, order is n by n, so it indicates this is a square matrix, and it is upper triangular matrix if Aij is equal to 0 for all I greater than j. So this is the symbolic definition of upper triangular matrix. Let us see one example. This is 2 by 2 matrix and it is an upper triangular matrix. See here, all elements below the diagonal are 0. See, this is the diagonal, and all elements means in case of 2 by 2 matrix there is only one element and that element is 0, so it is called as upper triangular matrix. See here, this is an upper triangular matrix. Okay, this is a triangle. If 0 is nothing, then this is, it looks like as a triangle, so that's why it is called as upper triangular matrix. Similarly, example of 3 by 3 matrix is like this. See, this is the diagonal, 1 2 minus 1 is a diagonal and all elements below the diagonal are 0, so these three elements are 0, then it is called as upper triangular matrix. Okay. Similarly, lower triangular matrix. See here, a square matrix in which every element above the diagonal is 0 is called as a lower triangular matrix. Okay, see here, a square matrix in which every element above the diagonal is 0 is called as lower triangular matrix. So see here, symbolically it is A is equal to Aij, n by n order is lower triangular matrix if Aij is equal to 0 for all I less than j. By example, it is very easy to understand. See, this is the diagonal and all elements above the diagonal is 0. Okay, every element above the diagonal is 0, so this is 0 here, so this is lower triangular matrix. And in case of 3 by 3 matrix, this is a lower triangular matrix. See, this is the diagonal and above the diagonal all elements are 0. Okay, so remember upper triangular matrix and lower triangular matrix. Now we will discuss the reduction method to solve the system of linear equations. So to find a solution of simultaneous linear equations, how will you use the reduction method? See here, consider the following pair of simultaneous linear equations in two variables. I will explain this for two variables. So see here, first equation, a1x plus b1y is equal to c1. Here a1, b1, c1 are constant and xy are variables. There are two variables. So we require another equation, that is a2x plus b2y is equal to c2. say these are the equation number 1. Now we will consider the 2 by 2 matrix formed by coefficient of x and y. So make the 2 by 2 matrix of the coefficients of x and y in the given equations. So this is a1, b1, a2, b2. Then the matrix x, that is the column matrix of the variable xy, and the matrix b, which is of constants on the right hand side, c1, c2. Okay, so a, x and b are matrices related to the given two equations. Now we will consider the following matrix equation, that is ax is equal to b. Now if you consider the equation ax is equal to b, then we get this step, and we know that there is a relation between the pair of simultaneous linear equations and matrix equation. Now after this, means after converting the given equations into the matrix equation like this, what we have to do in the reduction method, we have to use the row transformations to reduce the matrix A into an upper triangular or lower triangular matrix. Means by using row transformations, convert this matrix into either upper triangular matrix or into lower triangular matrix. Okay, and similar procedure or the same row transformations are performed on matrix B also. So after getting this matrix equation, you have to use the row transformation to reduce the matrix A into the upper triangular matrix or lower triangular matrix, and same row transformations we have to apply on matrix B. So and after reducing that matrix A into an upper triangular or lower triangular matrix, we can solve that equations to get the values of x and y. This is all about the reduction method. Now we will discuss actual examples related to this method. Okay, so let us see first example. Solve the following equations by the method of reduction. Now suppose these two equations are given to you. 2x minus y is equal to minus 2 and 3x plus 4y is equal to 3. Now see how will you solve this. First of all, we will write the given equations in the matrix form as ax is equal to b. So in that case, what is A? A is the matrix of coefficients. See here, it is 2 minus 1. See here the coefficients, 2 minus 1 and 3, 4, like this. Then matrix X is equal to xy, column matrix xy, and matrix B, which is of constant, that is minus 2, 3, like this. So ax is equal to b is the matrix equation, and hence we get the actual matrix equation like this. Okay, this is the matrix A into this is the matrix X is equal to matrix B. Okay, so we convert the given two equations into the matrix form or matrix equation. Now we have to reduce this matrix A into an upper triangular matrix. Now we will use the suitable row transformation. So what is our suitable row transformation? First of all, I will interchange R1, R2, row number 1 and row number 2. Interchange that. So see here, 3, 4, 2, minus 1. Same we have to apply on the right hand side. So here we get 3 and then minus 2. Why we do like this? See, we require 0 here. Here in this position we require 0, so that it becomes an upper triangular matrix. So before that, if we get 1 here, remember, first of all we require 0 here to get the upper triangular matrix, but before that it is convenient to do 1 here. So before converting 0 here, always remember, here you convert this element into 1. So how will you convert that? If you use the transformation as R1 changes to R1 minus R2, then see here R1 minus R2, that is 3 minus 2, that is 1. Then 4 minus plus 1, that is 5. It becomes 5, 4 plus 1. And second row as it is. And here if you apply that, then 3 minus plus 2, 3 plus 2, that is 5 and minus 2. And after getting 1 here, it is very easy to get 0 here. Our main part is we required 0 here, but before that we make 1 here, and for that we interchange R1 R2, then R1 changes to R1 minus R2. These two are extra transformations to get 1 here. Now this is very easy to convert 0 there in the row number 2. So if you change R2 as R2 minus 2R1, then you will get 0 here. See, so this is an upper triangular matrix. See here, R2 changes to R2 minus 2R1. So 2 minus 2, we get 0. Okay, then minus 1 minus 10, that is minus 11. XY remains as it is, remember, XY remains as it is equal to, here we get 5 as it is, and minus 2 minus 10, that is minus 12. So this is the main step, means we convert the given matrix into an upper triangular matrix. Okay, now the method of reduction is completed here. Now how will you get the values of x and y after this? Again reconvert this matrix equation into the linear equations. So if you convert that, then we get the equation, that is, if you multiply this first row into first column, then 1 into x, that is x, plus 5 into y, that is 5y, is equal to 5. This is first equation. And second equation will be multiplying the second row into first column. So 0 into x, 0x, minus 11 into y is equal to minus 12. Now see, after reducing the matrix of coefficients into an upper triangular matrix, and after converting this matrix equation into the system of linear equations, we get this equation number 1 and this as a equation number 2. And after getting this, we remove the value of we remove the coefficient of x. That coefficient of x becomes 0. So that's why it is very easy to get the value of y here. So what will you get? Here we get y is equal to 12 upon 11. Now by our usual method, if you put this value of y is equal to 12 upon 11 in equation number 1, so put value of y is equal to 12 upon 11 in equation number 1, then what will you get? See here, x plus 5 into 12 upon 11 is equal to 5. Now see the calculation, that is x plus 60 upon 11, see 12 into 5, that is 60 upon 11 is equal to 5, and that is x is equal to 5 minus 60 upon 11, then cross multiplying we get minus 5 upon 11. Check this. So after getting value of y, we get the value of x. So the answer, final answer is x is equal to minus 5 upon 11 comma y is equal to 12 upon 11. So we get the solution of the given linear equations by the method of reduction. Okay, you can verify your answer just by putting the values of x and y in any one of the equation. Okay, so check this. So this is the reduction method, means we have to convert the matrix A into an upper triangular matrix or lower triangular matrix also, but generally we use to convert upper triangular matrix. Okay, so that we get the values of x and y. So this is the first example. Now we will discuss another example also. Suppose the equations are x plus 2y is equal to 2 and 2x plus 3y is equal to 3. Then Again same, we have to convert this into matrix form, that is Ax is equal to B, where A is equal to, see this matrix 1 2 2 3, X is equal to xy and B is equal to this matrix. Okay, now write it in matrix equation like this. Okay, now we have to convert this matrix A into an upper triangular matrix. Now see, here we require 0, but before that if you make 1 here, then it is very easy to solve, but there is already 1 here, so we will not require any extra step here. Just if you use this transformation, that is R2 changes to R2 minus 2R1, then you will get 0 here. So as here it is 1 in the first row, it is 1 here, so that's why it is very easy that R2 minus 2R1 becomes 0 here. So see here, you apply here, so first row remains as it is, and 2 minus 2 will get 0, and here 3 minus 2 into 2, that is 3 minus 4, that is minus 1, and here this is 2 as it is, and 3 minus 4, again here it is minus 1. So we convert the matrix, that is the matrix of coefficient, into an upper triangular matrix. Now again write the equation like this. So we get x plus 2y is equal to 2. Multiply first row, first column, hence we get this, and second equation is 0x minus 1y is equal to minus 1. That is nothing but simply we get the value of y is equal to 1 by this second equation. And if you put that value of y is equal to 1 in equation number 1, then what will you get? See, very simple, x plus 2 into 1 is equal to 2. So that is x plus 2 is equal to 2, and hence x is equal to 0. So after converting the matrix into the upper triangular matrix, we get the value of y is equal to 1 and then value of x is equal to 0. So the final answer is x is equal to 0, comma y is equal to 1. So this is the solution of the given pair of linear equation. Okay. Now third example, x plus 3y is equal to 2 and 3x plus 5y is equal to 4. See, again by same technique, right here ax is equal to b, where a is equal to 1 3 3 5, x is equal to column matrix xy, and b is equal to column matrix 2 4, which is of constants on the right hand side. Then we write this equation, that is called as matrix equation. Now convert this matrix into an upper triangular matrix. Now if you observe here, then there is a 1 here, so it is very easy to convert the second row, that is R2 changes to R2 minus 3R1. If you change row number 2 to get 0 here, we will use this transformation, that is R2 minus 3R1. Okay, so what will you get? 1 3 1 3 as it is, and 3 minus 3 is 0, 5 minus 9, that is minus 4, xy as it is, and here if you apply same, then 4 minus 3 into 2, 4 minus 6, that is minus 2. So if you convert this first row into first column, that is x plus 3y is equal to 2, and 0x minus 4y is equal to minus 2. We get these two equations. Okay, so after getting these two equations, just see here second equation, by which we get the value of y is equal to minus 2 upon minus 4, that is after simplification minus minus become plus, and we get 1 by 2. So value of y is equal to 1 by 2. Now put the value of y is equal to 1 by 2 in equation number 1 and solve this. Then we get x plus 3 into 1 by 2 is equal to 2, that is x plus 3 by 2 is equal to 2. Then x is equal to 2 minus 3 by 2, that is again we get 1 by 2. So values of x and y both are 1 by 2. So x is equal to 1 by 2 as well as y is equal to 1 by 2. So this is the reduction method to get the values of x and y in case of uh, two equations, means equations containing two variables. In our next lecture we will discuss how to solve the three equations with three variables by reduction method. Okay, so try to solve this type of questions by reduction method. Thank you.